Hi, thank you for watching this short video. I am Oliver Rossi, Solutions Architect at DataCore Software, leader in software-defined storage. So we've just released Product Service Pack 1 for SenSymphony v10, which enables several exciting storage services. Today I really want to focus on one in particular, which is the Random Write Accelerator. As you probably guessed, this is our implementation of sequential storage. So in this demo, I will show you what sort of performance acceleration you can get or expect. But before I start with the demo, let me first start by describing briefly what our software-defined storage platform is. So DataCore was founded in 1998 with the idea of building what we call then software-driven storage. While major storage manufacturers were busy adding features to their array and capabilities to their array, DataCore actually built the same set of storage services in a software package that could be applied to any storage subsystem, right? And allowing already back then to break the vendor lock. So today, fast forward to today, the storage landscape, it's a big giant mess, right? We have SAN, NAS, direct attached storage, PCIe flash card running close to the application for performance acceleration, hyper-converged system, flash array, hybrid array, the cloud, with increasing requirement for business continuity and disaster recovery like never before, with systems that cannot talk to one another, that cannot be centrally managed. So this is why software-defined storage is such a hot topic today, because this is really the key to solve all these problems. So there's many claims to software-defined storage, right? This is what we at DataCore think it should enable you to do. So, break the vendor lock by enabling all the storage devices to communicate with one another, separate the features and capability from the hardware itself, pool all the storage capacity together and provide you with centralized management so you no longer have any silos of storage, and make the hardware maintenance, data migration, and hardware refreshes super easy to do. From a high level, SenSymphony V enables the virtualization of any block storage devices regardless of make, brand, or model, whether it's direct attached resource, internal storage, SAN attached, or even, the PCI flash card that I talked about for performance acceleration, right? We can virtualize all of this, and our software inserts in between the storage devices and the consuming host and application. And by doing so, virtualizes all the storage devices and enable this advanced set of storage services that you would expect from any high-end storage subsystem. So things such as synchronous replication, async replication, snapshots, CDP, auto-tiering, sequential storage, and so on and so forth. This is the complete feature set, right? As I mentioned, we are at version 10, Product Service Pack 1. We have over 25,000 deployment worldwide, so it is a proven solution that is used in the market today. What we're going to focus on today is what our marketing team has called the Random Write Accelerator. So in other words, it is our implementation of sequential storage. So without further ado, let me jump into the demonstration. All right, let's take a look at what sequential storage can do for us. Okay, so I am provisioning a 50 gig virtual disk from DataCore SenSymphony V to my desktop machine. So here, let's take a look at this virtual disk. It is shown up here as a 50 gig disk. Let me show you where that virtual disk is coming from. It is coming from a single DataCore server. So this is our management console. For those of you that have not seen it yet, this is our management console. And here I have a DataCore server in which I have created a pool based off really two basic desktop grade 2 terabyte SATA drives, right? And out of this pool, I have created this virtual disk called Sequential Storage Test. And I have provisioned the Sequential Storage Test to my desktop machine here over 1 gig iSCSI. Okay? So let's take a quick look at what IOmeter can do, what sort of performance we can see. We're probably going to see a very large number at the beginning. That's going to be due to our cache, but since it's a 100% random test, the cache is not going to do us any good after a while. So here is 32 outstanding IO, access specification, 4K, 100% random, 100% writes. Here it is. Result display. Let's take a look at the latest update. I'm going to start this test. Okay, so here's a high number I was talking about. You're going to see this die down pretty quickly. Okay, so essentially, all right, we're doing about 190 to 220 IOs. Let's take a quick screenshot of those results. Okay, so in order for me to actually enable sequential storage, I have to unserve this virtual disk. So I'm going to unserve from the host. Sure, here it is. Let's make sure it is gone from our desktop machine. So I'm going to quickly rescan, make sure it's gone. Yes, it is. Now let's take a look at the settings of that virtual disk. And you see here I have the ability to enable sequential storage, right? I'm going to say apply. Okay, so sequential storage is enabled. I am going to reprovision that virtual disk to my host. Here it is. Next. Finish, single path. It's a very simple environment. It's a single virtual disk, no redundancy whatsoever. Just the purpose here is to show you sequential storage and the type of performance acceleration it yields. So I'm going to rescan. Let's run IOmeter. Okay, let's open up our 4K 100% random write pattern. Select this guy, 32 outstanding, access specification. Yes, it is still the same, 100% 4K random writes. Okay, result display, yes, and let's start. Okay, so, well, here it is. Let's compare with the previous number, right? I pull IOmeter here. So, to the right, this is what we get out of 2 SATA spindles over 1 gig iSCSI without any sequential storage. And to the left, this is the type of performance acceleration we see by enabling sequential storage. All right, this concludes our demo. So to the right, the results without sequential storage, and to the left, the result with sequential storage. So without, we got 220 IOs per second with a response time of 156 milliseconds. Again, in my lab, I had 2 terabyte desktop grade SATA drives. The IO pattern that we used was 4K, 100% writes, 100% random. And so it's pretty bad results, right? And to the left, as soon as we enable sequential storage, or random write acceleration as our marketing team calls it, we saw drastic performance improvement, right? So 8,250 IOs per second and response time 3.8 milliseconds. So that's to conclude our demonstration. I hope you found this useful. If you want to contact me to talk more about this particular feature or anything DataCore related, I'm available at the following email address. You can also call me directly if you'd like. And if you want to try the software, you're more than welcome to download it and give me a call. I'll be happy to help you set it up. Thank you very much, and thanks for watching.